Hey folks, welcome to Advent of Code in F Sharp. Day 25 already. Sadly, last day of the Advent. It's been a tough year, or uh, it's been a difficult year. The puzzles, I mean. As you can see, I have not finished all of them. I even have not started on two of them because they're way, way hard. I don't remember day 23. Oh, yeah, this one. The one where I think solving it manually will be easier than programming it. Or But anyway, let's take a look at day 25. Bygones be bygones. Noses to the future. Let's take a look. Sea cucumber. This is it. We've reached the bottom of the ocean trench. Last place the slakies could be. Our antenna still is not boosted enough to detect them, but they must be here. All you need to do is reach the seafloor and find them. At least you'd touch down on the seafloor if you could. Unfortunately, it's completely covered by two large herds of sea cucumbers. What do sea cucumbers look like? Fancy. And there isn't an open space large enough for our sub. You suspect that the elves must have done this before, because just then you discover a phone number of a deep sea marine biologist on a handwritten note taped to the wall of the submarine's cockpit. They're probably hunting for food, but don't worry, they're predictable critters. They move in perfectly straight lines, only moving forward when there's space to do so. Okay. You explained that you'd like to predict when you could land your sub. That's easy, they'll eventually pile up and leave enough space for... Wait, did you say submarine? And the only place with that many sea cucumbers would be at the very bottom of the Mariana... the Marianas Trench. Cool. There are two herds of sea cucumbers sharing the same region. One is always moving east, while the other always moves south. Okay, so we have easters and southers. Each location can contain at most one sea cucumber. The remaining locations are empty. The sub generates a map, for example. Yep. This doesn't sound too bad. This does not sound too bad at all. Every step, the cucumbers in the east-facing herd attempt to move forward. Then the sea cucumbers in the south attempt to move forward. When a herd moves forward... Okay, so it's first east, then south. When a herd moves forward, every sea cucumber in the herd first simultaneously considers whether there is a sea cucumber in the adjacent location. Even another in the same direction. That's interesting. Okay, and then every sea cucumber facing an empty location moves into that location. So when you have all facing east, only the first one detects that it can move. And then we have two with a space in front, and then we have three. Okay, that's an interesting test case already. Cool. During a single step, east facing moves first, then south facing moves. So this is a valid... This is not. Okay, makes sense. Due to strong water currents, the sea cucumbers that move off the right edge of the map appear on the left edge, and sea cucumbers that move on the bottom appear on the top. So we wrap around the sea... We wrap around the map edges, cool. And they also check whether or not there's a sea cucumber there. Cool. We need to find a point where sea cucumbers stop moving. What does stop moving mean? Okay, we need to find a fixed point. Today the power of fixed point will shine. This is... I thought it would be easier today, but no problem. No problem. I feel very much like solving today's puzzle. So let's give it a try. It is a pretty big map. 137 by 137. Let's grab the somewhat big example with the 58 steps, sure. That's the initial state right there. And let's think about this. We have a finite grid of 1, 2, 3. Yeah, we have a small finite grid. We need to wrap around. I'm going to go for array 2D today. We don't have a sparse grid, so let's parse our sea cucumbers into an array 2D. There are two different kinds. I like types, so let's introduce a type. A cucumber is either facing east or south. Our array 2D, that's our map. That's a map of what? Cucumbers. I say map, but I mean 2D array, of course. And that's it, probably. We just need to parse. What do we need to be able to do efficiently? Look at neighbors and move stuff. Yeah, cool. Okay, let's parse our example. Let's give it a shot. So, for row in example. Example is a list, right? Yeah. Or an array. So for every row, let's parse a cucumber. That's a function that takes a character. If it's a east-facing character, we have an east cucumber, and if it's a south-facing, we have our south. How is... Oh yeah. How is character a string instead of a character? This is better. Match cases were... Oh yeah, we have dots. We have dots. Yeah, that's true. We do have a sparse matrix. Let's take a look at our input. Do we have a lot of dots? No. Okay. How shall we model this? As another case? Yeah, that's going to be easiest. So we have empty. That's not really a cucumber. It sounds a bit weird. But otherwise would have to... otherwise a map would make more sense. In array 2... yeah. If I'm going to model it using an array 2D, I'm going to explicitly represent all the different states a place in the map can live in. So we have our little universe. It starts with a south, then 3 empties, then 2 easts. Yeah. South, south, east, empty. And we need to parse into a 2D list, so let's do that as well. Yep, and if we make this an array 2D, we have our grid, which is our map. I'm going to explicitly type it to make sure we did not make any mistakes. It's a map. Cool. It's a map. A map being an array 2D. Way to choose my names, but okay. I think this is a parse. Yep. So I'm going to wrap everything in a function. And we'll return map. There we go. So here we need to parse the text. Come on. There we go. And if we parse the example, that should still work. Yes, input should also work. Takes a that takes a bit longer. Okay, cool. And let's get a this in a variable so we can start playing. Okay, what do we need? East, move first, south, move next. We need to keep moving until the map does not change. Can I do a structural equality check between two maps? Yes, appears like we can. Let's look at array2d. I don't use it all that often. Do we have filter? No. Ah, that's a shame. We can't easily access all the east facing. Okay, can we do array2d.map? We can. Builds a new array. That's, yeah, let's use a map. Let's map over all elements in an array. Does this keep track of the index? No, it does not. Why do they prefer a map over, or an array2d over a map? I don't know. I'm missing all my fancy functions. Okay, we can manually iterate using for comprehensions again. But then what's the... Yeah, let's do that. It's because it's new, let's do it. Or because it's unfamiliar. So let's first try to move all east-facing cucumbers. Yeah. Oh, you have a map I, right? That's probably something that'll grab the index for me. Yes, okay, this is something we can use. So let's first try to move all east-facing cucumbers. Yes. So in our map, we are going to map over every element in the map using mapped I, so we get row and column. And a cucumber. This should be identity. This should leave our map intact. Okay, and now we take a look at the right neighbor. Wait a second. Map I gives you an array of U's, but the U's are in the same index as the T's. Yes. That's not really what I want. No. It's the indices that change if they move. Okay, this was the last straw. I'm even contemplating is a single data structure. Yes, it's easiest because we have. That's going to be easiest because we have. They both live in the same universe, so representing them in one thing is going to be easiest. But I am going to get rid of this. Array2D, it was a nice experiment. I don't feel it. So let's build it as a cucumber map. Cucumber map. There we go, there we go. And this becomes a map dot sequence. And we need to indices for that to work. So there we go. And then we have row number, row. And we have col number and column. Yep, parse and store the row column. I don't know why I said RNCN. Let's do it RC. I thought this would work. Maybe we need a flat list for a map to work, to have a key value thing. Yeah, this still works. Cool. It's completely unreadable now. Small side effect. But okay, now we have a map. I think this will be easier. Is map a keyword? No, okay. Yeah, we have our map, and now it's an actual map. Now it's going to be easier to filter. We don't even need the empties, right? No. Can I do where? Or if? So we get when? Can I do a guard in a for comprehension? Probably, but not on the left-hand side of the arrow. So if, then yield. Otherwise, forget it. Yeah, I'm liking this approach way better than... I'm liking this approach way better than the read to T one. So now our cucumbers are not empty anymore. They're only east, only south. That makes more sense. So we have our map. Let's grab all the easts and see if they can move. What does filter return? Another map. Oh, why the heck not? What does this return? It's predicate on key and value. Okay. Then it makes more sense to do this. So location, don't care. Cucumber, do care. Cucumber has to be east. So these are all the east facing. Yeah. These are all the east facing. Now all the east facing that are spaced to the right. I'm thinking what would be the best outline? Does it make sense to keep it in a map? Yeah, for all the work we're doing, we don't really need a map, right? No, we don't. I don't, so probably this won't be the best. Data structure, but let's drop out of map world. It makes no sense to stay in map world. So these are all the easts. I'm thinking of three things at the same time. Bad idea. But what I'm thinking about is, what I would like this to look in the end is like we have map, and then we have a function called move the east ones, and then we have another function that's called move the south ones, and that function just iterates over. Or we could even do a single function. Nope, east have to move first. Yeah, so that's the general outline. So map, move easts, move souths, and that's one iteration of our fixed point thing. And we just keep doing this until the map does not change anymore. Yeah, so these are our easts where we check whether or not they can move. Now, in order to move, we need to calculate the next coordinate. For that, we need their location, not the thing itself. And location is what? Row column? No, let's do a function. Next east of location. And let's keep the original location and the original cucumber in there. Can you not use an underscore? Probably you can. If you use it, you need to use it. Yeah, cool. Let next east location. It's just the to calculate the offset or to calculate the coordinate to the right of us. So that is what is to the right? That increases column by 1. Am I doing it right? If you do row next, that's south. Yeah, okay. So we increase column by 1, that's east, but we need to wrap around the length of the map. So this is 1, 2, 3, length of 3, then we have a location at 2, so it's 0 based. We need the dimensions of the map. We need the dimensions of the map. Rate 2D would have been better here. Max row. Can I do sequence.max over a map? Probably, but then we'll get some funky type, I think. Key value collection. Yeah, key value pair. What can we do with key value pair? Actually, this will work. So grab the... No, I don't like to see this. So we have all the things, and then we say... Map all the things to their row is the first thing, so row, column, there we go. And I want to take the maximum row. And let's do the same for column. So that is, column is right here. That should give us something 8. I am going to believe that it's an 8 by 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it has 10 spots. So that's max row, max column. If we move east, we do this, but need to wrap around a max column. So max column is 9. That means we can go from 0 to 9. So we should get from 0 to 9 and then a 0 again and then a 1. I'm just gonna try some list.map fun. So this should be whatever and a column, and let's map that to next east, just to verify whether we're doing the right thing here. 1, 2, 3, 4, 8, 9. Nope, it's not wrapping around correctly. Interesting. Should I put parentheses around here? So it's 1, 2, 3, 4, 5, 6, 7, 8. And at 9 we drop, that's 1, 2 short. What am I even doing? Oh yeah. We need to go 1 to the right, sorry. So we should have 1, 2, 3, 4, 5, 6, 7, 8. 9 should also be valid, right? So it's modulo max column plus 1. That was what I was not too incorrect. 9 is valid, then we wrap around. Yeah. Cool. So we have an next east. I'm already moving ahead and doing a next south, where we increase row by the same thing. This becomes row on max row. And column stays as it is. So these are all the east moving. Then we say grab their next locations. Yes, grab their next locations. And now we need to look at, is it free or not? So let's look up what's in the map on that spot. So we can do map, try find at that location. This should give us everything. This should give us everything. This is becoming unwieldy. Let's put this in its own little function. Yes. Next location for... Oh, it's the next east location for... Yeah. Cool. Okay, we are where we were again. So next location for a location and a cucumber. Let's feed in map. We have been using map as a global variable. Let's move away from that slowly. These are the east ones. This is calculating the next location. Yes. Okay, let's extract all these things. So that's the location. This is the thing at the next location. And let's match on that. Okay, now it becomes clear. If we have nothing, we have our next location, which is this thing. So we try to move east, given the current location. If nothing is there, okay, now we're getting somewhere. It's the next location for this one. Otherwise, we stay where we are. We don't even need to know which kind of cucumber it is here. That is true. Or we can do the branching in here. Let's do the branching in here. Yeah, sure. So if... Let's match our cucumber here. If it's an east, we do next east. If it's a south, we do next south. Okay, this looks cool. So first we grab our east facing cucumbers, then we try to find the next location for each and every one of those, and we map. And instead of just giving the next location, let's also return the cucumber itself. So this maps to sequence of tuples, and I think we can do map sequence here. So we're back in map world. Cucumber map, sorry. Yeah, okay, so the types line up, but problem is we only updated the east ones. We want to keep track of the south ones as well. So these are the next east. What do we want to do? Do we want to smush these in? Yes, we want to smush these in. So I'm gonna grab all the south ones. Don't know whether or not I like this because we're doing a lot of accessing, but okay. So we have all the south ones. Let's append the updated east ones with the south ones and smoosh them in the map. And this is where I don't like it anymore. But anyway, this is our cucumber map with updated easts. There we go. And we need to do this not just for the easts, but also for the souths. So this is actually move east. What do we need for this to work? The map, because we are going to fill it in. Yeah, I think that's it. Something is using the dimensions, right? Oh, those next ones. Yeah, okay. Let's forget about it. Let's not feed in anything. This moves all the cucumbers that can move east. Let's now write a function that moves anything that can move south. It's largely the same. We grab the souths. We grab the easts. Our next map is the souths, where we try to find their next location, which does the type check, yeah. And we append the south, so the east's back on it. And we're done. Yeah, so this is a single step, if I write out the function names correctly. We do need the map. We are going to update the map. Of course we need the map. Does it matter that we are not feeding in the dimensions? Those stay the same. It's tricky. I would prefer to feed them in, but then we'll need to feed them into the entire stack right until the lowest function. Yeah, I'm not gonna bother. This is a single iteration. Let's see whether this is correct already. Let's maybe use that small example we had. So I'm gonna write a function step, which takes one step. Let's go back to the small and simple examples. So this one, let's see whether or not we can take the steps we need. So we have this one, we parse it, we take a step. Did we not have a parse? Yes, but it needs to be a sequence. This is a sequence. Cool. 3, 4, 5, 6, 8, yes. And then we had 2 move, so it'll be 7, 9. Yes, and then we'll have 6, 8, 0. Wait, why is 5 moving already? Wait. Let's see that again. And maybe I should print it out as a... Yeah, let's write a quick print function. That'll help us out. So, iterating over all the possible indices again. Yield. Yes, let's match on whether or not we find something. If we find nothing, it's a dot. If we find something, if it's an east, we print out the right arrow again. If it's a south, we print out the down arrow again. Can I not do an inline function thing? This function takes too many arguments. Oh yeah, we'll need C match C with. Yeah, that's better. I was mixing my option functions and explicit pattern matching. For a single row, we'll concatenate all those things. Yes, let's make all those things strings so our string concatenate works. Oh, come on. There we go. And this can be a string as well. This can be a string as well. And yeah, at the end, let's concat all new line. And then we have a single string. Yeah, so I think we can print maps now. Let's try that out. Yikes. Oh yeah, that's because max row, max column. Okay, this convinced me. We don't only need the cucumber map. I'm gonna make a slightly smarter data structure, something that has a map, but also max row, max column. And that's these two. So this is the map itself. Oh, and by the way, we have max row and max column. And if we return the entire thing, taking big steps here, I would normally not take big steps or steps that are this big. Let's see if we can parse this new data structure. Yeah, cool. And now let's see what's happening here. What's our first thing? Step is our first thing. So move east is our first thing. Map is an entire map. If we do map.map, I'm using a lot of maps today. Map. Next location for map dot. Nope. Here we need the entire map. If we go here, this is the entire map. Next east takes an offset as well, which is max column. And that's this thing. This takes a max row. That's this thing. So let's feed it in map.max row. Cool. This is starting to look better. This is not a cucumber map. This should be a cucumber map. And we update the map. There we go. Easy peasy. The only thing I don't like is the amount of duplication here, but it's only 2. Need to do the same thing here. It's not a cucumber map here. It's a cucumber map here. Almost done. Way better. Cool. Let's give this another shot. Way better. Way better. So our initial map looks like this. That's right. We don't print out the empty things on the right. Ooh, is that a problem? That is a problem. That's not correct. That's a bug. We need to max. How do we calculate max row, max column? There we go. This is not correct. This is let's take the number of rows. That's going to be better. And column is the number of characters. So let's take the first row and put a dot length on that bad boy. There we go. That'll be better. Now our printing will actually print out the entire universe. +1. Why? What? I give it 1 line. Oh yeah, it's off by 1, of course. I'm wasting so much time. Why is max column not doing the same thing as max row? It'll probably be the same thing, right? We have 3 dots on the left and right. Yeah, okay. So this is a single step, finally. Oh, this is no steps at all. This is a single step. Okay, this is starting to look better. Yeah, this is starting to look better. I think we have everything we need. Let's try the example. It's doing something. Let's print it out with an actual print statement. So let's print out a string. And now we should see it better. No? Why is it not printing out my... Okay, forget... Forget I pushed everything into a string. I'm just going to print. Yeah, so I'm gonna print... what am I doing here? This is a row. This is the entire string. No, I should be able to figure this out, right? Why is this not printing the way I think it is? Why is there a new line character? Because a new line character is this one. Oh dear. It's 25 days of Advent of Code. That's when I start to do stuff like this. Yes, much better. Okay, assuming this is correct, we'll figure that out in a second. Let's write a fixed point operation. So fixed point is something, a way to achieve like a stable point in time. So this problem is like literally a fixed point calculation. You do something, you do it again another time, and you look at the two states. If they're not identical, you just keep doing that until you reach 2 subsequent states that are identical. So let's find a fixed point here, given a map. And that is literally we do the next one. So next is take a step for the map. And if next equals map, then we are done. Otherwise, we recurse and do fixed point again with next not map. The only thing we need is to find the generation. We don't care about the end state. We care about the number of steps. Yeah. So we return the number of steps, and otherwise we increase the number of steps. This is a fixed point operation. And let's call it fixed point step whatever 1 given our map. So this is solve. Hello? Hello, dear REPL. Where did you go off to? Oh no, is my fixed point crashing? I think that was what we were seeing. My fixed point was looping infinitely. Yeah, there we go. So our map is the example, and let's try to reach a fixed point here. It's going off. Oh no. Why do my example, why does it go off? Yeah, let's print it out in the actual thing so we don't have to keep repeating ourselves here. So after one step, I would expect this to look like... Wait, that's not the same example. Hey, cheeky, cheeky. Yeah, that's not the same example at all. That's my bad. I misread. So this will work better. Cool. Yeah, looks correct. Let's see if we can solve this one. Ah, we cannot. Okay, so let's print out in every step of the fixed point. Let's print it out and see where we go wrong. I use a REPL to, like, in my head it was faster than a compile cycle, but if you have infinite loops like this, it's not faster. The boot sequence takes a very long time. I should put new lines in there, right? Wait. I thought I saw the problem already, but nope, our print needs a new line. I'm just gonna print a new line, hardcode one in there. Okay, one more time. How long have we been working? 50 minutes? That's way longer than I would have hoped. Okay, stop now. Cool. That's not stopping. I'm gonna do one more thing. Let's print out n as well. We should expect it to stop at 58, right? Was it 58? Wait. I am taking the wrong... Sorry for this. I am taking a wrong example. This one should stop after 58. We have a smaller example. Maybe we should look at that first. Anyway, let's do the big one first. Let's see if we can figure out the obvious problem. Okay, stop. We're at 1,000 already. 6,000, 12,000. Okay, you can give up now. Let's see what we got here. Let's cross-check. Let's cross-reference these with what we have here, and let's see if we can find out an obvious problem. This looks like the initial one, yes. Then after one step, what changes? A lot changes. That looks somewhat correct. No. Oh dear. What's happening at this bottom? What's happening at the bottom row? First row is already incorrect. It looks like we're throwing away... It looks like we're throwing away cucumbers that wrap around. Am I interpreting this correctly? No, this one. Where did this one go? That should remain as is, right? It tries to move right, but it can't, so it stays right. And here, it tries to move right, and it just poof, disappears. We have a bug, yeah. So it's in our move east. These are the east ones, yes. And let me say, try to go to the next location. It's an east one, so we should go to the next east. The one thing I don't understand is I think if we count the number of cucumbers, I think we're losing cucumbers. How can we lose cucumbers if we do a map dot map? The only point in code where I see things getting lost is here when we have duplicate coordinates. How can we ever have duplicate coordinates if there is a bug in here? Yes, if there's a bug in here. So either our wrapping and our modulo thing does not work, or our wait. Next is the next location. If we find nothing, it's the next location. Otherwise, is the original one. That sounds correct. We don't care what's in the next location. That's true. Don't see it. Let's grab that smaller example and take I think the problem is in wrapping around, right? So let's take this beaut of an example. Why can this third one not move? Oh yeah, east moves first. Okay, yeah, that's a good example. Let's print out this example. How many steps preferably? 4. Ooh, we already have our bug. That's easy. So we can start troubleshooting. This is initial state, yes. And then we take one step, just the one. I find it hard to believe even. So this is our next. Let's count the number of we have 1, 2, 3, 4, 5, 6, 7, 8. And if I print, we have only 2. The bug is in our printing? Wait a second. Wait a second. What is our map? Our map is something that says 7 by 7. So that means 0, 1, 2, 3, 4, 5, 6. Oh. Oh. I see. Off by 1 errors. Even in a functional language, off by 1 errors. The bane of a programmer's existence. Where did my screen go? There we go. So, what does this look like? Let's get rid of everything. Cool. After one step, still not really correct. This is correct. This looks correct. What happened to the last column and the last row? Okay, we have fiddled with indices. Never a good idea to fiddle with indices without tests. That's a heuristic I just invented for myself. That's better. Cool. Let's take another step. Yeah. Let's take another step. Let's go all the way with this example. Yeah. Let's take the 4th step. We are getting somewhere. Yeah, that looks correct. Cool. I'm gonna try solving the... What is map? Let's grab the big example again. And let's try to solve that one. So let's do example, parse, solve yet again. Nope. Shoot! I'm getting a bit frustrated because it's going to be an 0 by 1 again. I should have cleared my console before I did this, so let's do that quickly. I thought I'd fly through this in, what, half an hour? I guess not. How long have we been coding? Small hour? Okay, that's still way below my threshold. Yep, there we go. Oh! What changed? I don't know, but it looks correct. We have 58. 58 was correct, right? Yeah, so I'm gonna put that single thing in a test. Not that it will do much. And it's not solve example, it's example, first parse, then solve. It prints a whole lot of things. Let's not print. This is the printing thing. Yeah, that works. So let's run it on our input. Uh-oh. Ruh-roh. I'm gonna print the generation or the number of iterations just so we can keep track. What's happening? Number crunching, that is what's happening. And probably it's because I am doing a lot of map to sequence, filter, then appending it in a list again, and then making it a map yet again. That's not, no. Yeah, if it's a big number, we have a problem. This is very slow. How can we speed this up? I think I highlighted the pain points. Doing lookups in maps is slower than doing lookups in array2Ds. That is for sure. If we would have stuck with the array2D thing, what would have been harder? This would have been exactly the same. Oh, we have an answer. It's not that much of a problem. I thought it would go in the millions again. Cool. But part 2 will probably. Let me grab my hit window. That's not my hit window. Where's my source control thing? There we go. So we'll probably have to refactor towards something way more performant. Oh no, it's done. That's cool, but also sad, but also cool. So we are done, I think, except for the little fact that I don't have a... You don't have enough stars to boost the signal? No. I'm just going to do a quick read. If you prefer no spoilers, look away now. I'm not gonna narrate. Oh, I always love these stories. It's a thin story, but it is a story. Yeah, I need 6 more stars. This was a fun puzzle today. Short but fun. Maps are not the answer to everything. That's something I have learned. We need 6 more stars. So 1, 2, 3, 4, 5, 6. Yeah, that's all the missing ones. Day 19. I don't look forward to solving that one though. Anyway, I had fun with today's puzzle. I hope you did as well. I'm not sure if I'm going to catch up on these missing stars. Who am I kidding? Of course I'm going to catch up on these missing stars, but maybe after the holidays, when I had a bit of rest. This was Advent of Code in F Sharp, or at least for now. Happy holidays. I hope you'll spend some time with family and friends. And we'll see you soon for another fun programming excursion. Thanks for watching, and until next time, bye-bye.